This is the first video in a series of videos covering linear relationship from the Stage 5 New South Wales Mathematics syllabus. In this video I'm going to look at the gradient-intercept form of the equation of a line and the different aspects of it in both the equation itself and its relationship with its graph. In this video I'm going to assume that you already know what gradient means and also what x and y intercepts are. So consider a line, let's call it L1, and let's say we have already been given its gradient, and the symbol for gradient we know is m, and also its y-intercept. So that graph could look like, as an example, this. So here's my y-intercept, and we know that gradient is rise over run, so we have some gradient m. And we know for this particular example the gradient is positive because the graph is rising. So the gradient-intercept form of the line is the one that we're most familiar with, written as y equals mx plus b. Sometimes you'll see this as y equals mx plus c. It really doesn't matter because b and c, they're just constants and they represent the y-intercept in both cases. So the pronumeral that's used is irrelevant, they represent the same value. And m is our gradient. Now you would have done some patterns in years 7 and 8. I don't know if you remember, for example, we might start with 4 lines to make a square, and then we add 3 lines to it, and then we add another 3 lines to it, and we continue that pattern, and from that you had to come up with a relationship. And in this case the relationship would be every time we move from one to the other we're adding 3 lines, so that would be my gradient 3x, and if I look at the first one, there's my 3 lines, I have 1 more to add. So we started looking at this sort of things a couple of years ago, but we're now moving from these shapes into more abstract mathematics where we're learning general knowledge that we can apply in multiple situations. So if you are given an equation of a line, say y equals 2x plus 1, I know that this line has a positive 2 gradient and it must pass through y-intercept 1, so the x value is 0, y value is 1. If I have a line that just has an equation y equals 2x with nothing here, then I know that it has no y-intercept. Well, it does actually have a y-intercept. The y-intercept is 0 because we are adding nothing to it. So what does that look like on our number plane? It must cut through the origin. That's where y is 0. So y-intercept here, remember at y-intercept x must be 0, y is also 0. Let's take this graph again with gradient 2, but what if it said 2x minus 5? Well, again the gradient is positive 2, but now the y-intercept is negative 5. So what do these graphs look like? If they all have gradient 2, what does that really mean? I'm not going to draw that. I want you to think about, come up with a hypothesis, and then you can use an online tool like GeoGebra or Wolfram Alpha to graph those lines and check your hypothesis to see what they look like. I am going to suggest, to assist in that, for you to sketch the graph of, well, let's do that, negative x plus 1. So in this case, y-intercept positive 1 and gradient negative 1. So let's sketch this. Now, since the gradient is negative 1, the graph is going down. X, y, y-intercept is 1. And for every 1 unit across, I'm going 1 unit down because it's negative 1. So we'll go through those 2 points. I don't have a ruler, so there's my jagged freehand drawing. 1, 1. What happens if I shift this graph exactly as it is, if I translate it down 2 units? What happens to its gradient? What happens to its y-intercept? You can pause and have a look at that and come back, or you can listen on. If the gradient is the same, because I'm not actually moving this graph, shifting it up or down, I should say rotating it up or down, I'm grabbing it exactly as it is, and moving the whole thing, sliding it, translating it 2 units down. So my gradient should stay the same, and it's the y value that changes, so the y value becomes negative 1. If I took that graph and shifted it up 3 units, translated it up 3 units, then I would have y equals negative x. The y-intercept now is going up by 3, so that would cut at plus 4. It's really important to understand what the significance of gradient and y-intercepts are in this equation, y equals mx plus b. What happens to the shape of the graph as those values change?